Okay, this is assignment 1, question 5. Given an integer array of zeros, ones, and twos, sort and print the array. We'll start with the function definition. We'll return nothing. And our input is going to be an integer array. We'll name it ARR. Let's open up these brackets. So we're going to declare some variables. We'll have an integer L for the left-hand side of the array, or the tail. We'll initialize this to 0. We'll initialize an integer R, similar to how you'd use a head, and this will be the length of the array minus 1. We'll have an integer mid that will behave somewhat like a partition. It's mostly our counter, so this will begin at 0. And we'll have an integer called hold value. This will be used to help us switch some values. So what we're going to do is we'll have an outer while loop. While mid is less than or equal to R, we're going to switch on array of mid. So mid is acting as our iterator here. We're going to have 3 cases. We'll have the case when array of mid is 0, case when array of mid is 1, and case when array of mid is 2. So in our case 0, we're going to essentially, so when we're going through this array and the value we find at array of mid is 0, we're going to throw it to the left and put the element that was in that spot into the middle. So we'll store array of L in hold value. Put the current value of array of mid into array of L. Assign array of mid hold value. Increment mid, move past this element, and increment L. Move the tail up 1 and break. We'll close this case 0. We'll open up case 1. So when array of mid is 1, we're going to move past it. We'll increment mid. In this way, as we throw all the zeros to the left, leave the ones alone, and throw all the twos to the right, as you'll see in case 2, we'll end up with a sorted array. It's really pretty awesome. So let's open up these brackets here. Again, we'll use hold value to hold array of R. Assign array of R the value of array of mid, and then assign array of mid the hold value. Now we're going to decrement R and move away from that 2 that's all the way on the right hand side. That would have already been sorted. Let's close this case. We're going to close the switch statement and close the while loop. Now our array will be sorted, so we'll just print all the elements in the array. Awesome, still in screen. We'll print the ith element and put a comma and a space so it prints nicely. Close this for loop and we'll close the function. Let's try out a sample array. Where do I have room? I'll put the sample array here. So array, we will assign this. Let's put everything out of order so it gets fun. So 1, 2, and 0 is our arrays of 0s, 1s, and 2. Well, I'll put it here. While mid equals 0, because mid is initialized to 0 before we enter the while loop. So we enter the while, mid is less than or equal to R, because R's value right now is array.length minus 1, which is 3 minus 1 is 2. R is 2. L is 0. Okay, so while mid is less than R, 0 is less than or equal to 2. Enter the switch statement. We'll switch on array of mid. So the 0th element is 1. We enter case 1. Mid is incremented. So mid is now 1. And we break. We exit out the switch statement back into the while loop. Mid is now 1. That is less than or equal to 2. We're going to switch on array of mid, which is array of 1. So we're going to switch on 2. We'll enter case 2. Hold value, call it HV. Hold value now holds array of R, so array of 2, so the last element. So hold value now holds 0. Array of R is assigned to, or array of mid is assigned to array of R, so 2 is assigned to array of R. Let me draw out the array so it makes sense. So what we had after the first step is we moved past the 1 and we still had a 2 and a 0. So now what's happening for mid equals 0. So now what's happening at mid equals 1 is, this 1 is still here, but array of r, so array of 2 is being assigned array of mid, which is 2. So this 2 is getting put over here, and then array of mid, so array of 1 is hold value. Hold value was stored as 0, so 0 is now here, and we're going to decrement r. So now r is 1. And we're gonna break. Oh, here's a break. Let's add that in. Perfect. Break goes right there. And so now mid is still less than or equal to r, because 1 is less than or equal to 1. So we enter the switch statement. We're gonna switch on array of mid, which is this 0 here. So mid is still 1, and this 2 is where he should be, but let's see what happens to this 0 and this 1. So case 0, hold value gets array of L is still 0, array of 0, the 0th element is 1, so hold value gets assigned 1. Array of mid is 0, that gets assigned to array of 0, so now 0 is over here. Hold value gets assigned to array of mid, which is array of 1, which means hold value goes here. And now we increment mid and we increment L, so mid is now 2, L is now 1, and we break. Let's come around and check if we still satisfy this condition. While mid is less than or equal to r, mid is 2, r is 1, mid is not less than or equal to r. So we're out of the while loop, and now we print every element in the array. So we print our array. For I equals 0, I equals 1, and I equals 2, we print all of this, which would give us and 2. Awesome. Let's analyze the space complexity and the time complexity that we have here. Let me just show you, that was the last array that I was writing. Okay, so let's analyze the time complexity. We only loop for every element of this array once, so our time complexity is going to be O of n for linear time complexity. And our space complexity, we're only initializing some head and tail variables, nothing approaching the size of the array. As the array increases in size, the amount of variables we need will not increase. So space complexity is constant O of 1.